to come back to one of our rapid fire questions, and also one of the highlights you brought up. So brain-machine interfaces, machine learning. So this is actually a trend that we as editors have seen emerging in neuroscience, and actually, quite frankly, a lot of other fields of science. So not only brain-machine interfaces, but also using machine learning to classify individual cell types, or finding neuroimaging biomarkers of mental processes or disease.
Big data,
Exactly.
managing this mother of big data that neuroscience is, right?
Exactly. So what do you think of these types of applications? Do you think that we're going to get some new insight into the brain, or will it really be a tool?
Well, we absolutely need it, because the data we're generating, we just can't analyze. We can't. So I think it's going to revolutionize how we do science. So even in my lab, where we're do molecular biology, we're very reductionist, but now we're imaging animal brains, mouse and brains, where we can image every synapse in the brain. So we can image using fluorescent markers. So we can image 1 million synapses at a time, and then we have an animal do behavior, learn behavior. So we're looking for changes in synapses. But you're looking at a galaxy, right? So you're looking at a galaxy, and you're expecting, small changes. How do you detect it? So we can't do that. And we could do it with 10,000, but 1 million or millions at a time. So now we're collaborating with people who do that type of image processing, and using machine learning techniques to detect the synapses and align them over time and look at intensities. And it's been revolutionary. So we're not quite there yet. These data sets are, even to the people who work with, the galaxies, our data sets are pretty big, they tell us. So, so that's how I'm viewing, it's going to, as a technique really, it's going to help us make more discoveries.
And this is a big topic of the Brain Initiative, right? So the first 5 years of the Brain Initiative has been really on building these techniques, right? These amazing tools to go from micro to meta, and be able to sort of have them look at the same chunk of brain all the way from like at the subsynaptic level to the functional MRI and beyond, like the gross structure, all the way up, and all the cellular diversity. So the Brain Initiative now has appropriately turned itself also to, how do we manage this data? How do we build the computational artificial intelligence to actually manage this data, and within all of its complexity? We are dealing with the most complex organ in our bodies, so it's going to be really a big challenge, and that's a big chunk of the Brain Initiative now is around this, managing and sharing the data. So because everybody's going to look at it in a different way, and I think so. Then I might take back, maybe it is consortia, not small labs, because the consortia will actually, everybody, it's like it's an elephant and everybody's looking at a different piece of it. And you kind of want that. You want people carefully looking at different pieces, but then bringing it all together. So that's the big challenge of how do we, connect all these small labs that are all doing incredibly useful, important things, and are expert at it. And you wouldn't want anybody else doing those things.